Today's is the 14th session and I am going to go ahead with coordination chemistry. After completing the inner and outer complexes with chromium, today we shall go ahead with the valence bond theory, inner and outer complexes with coordination number 6 of iron. Recollecting the valence bond theory, the central metal atom in the complex makes available an adequate number of empty orbitals for the formation of coordinate bond with suitable ligands. The appropriate atomic orbitals of the central metal atom uses its s, p or d orbitals to give equal number of hybrid orbitals, and the hybrid orbitals are going to be directed to the ligand position according to the geometry of the complex. So, the central metal makes available the adequate number of empty orbitals for the formation of coordinate bonds, and the central metal atom uses adequate number of or appropriate number of s, p and d of the metal atom and gives equal number of new hybrid orbitals. These hybrid orbitals are directed towards the ligand position according to the geometry of the complex. Each ligand has at least one orbital containing a lone pair of electrons. Each ligand has at least one orbital containing a lone pair of electrons. The empty hybrid orbitals of the metal ion will overlap with the fully filled orbitals of the ligand, forming ligand-metal coordinate bond. If the metal atom or ion uses its n-1d orbitals or subshells, it is called an inner complex, and if it is going to use nd orbitals in the formation of a coordinate bond, it will be called an outer orbital complex. So, if the metal atom is going to use its inner d orbitals, that is 3d orbitals, it will be called as inner orbital complex, and in this, supposing it is going to use 2d, 1s and 4p, it will be called as d2sp3 hybridization. But if it is going to use the outer d orbitals, it will be called an outer complex. Now, in today's class, we shall be going ahead with the complexes of iron, and at present we are going to study the inner complex of iron. One such example for an inner complex of iron is going to be hexacyanoferrate 3 ion. In this case, what do we observe is iron has an atomic number 26. With iron atomic number 26, the electronic configuration would be argon 3d6 4s2, and in its +3 oxidation state, here it uses 2 vacant 3d orbitals, 1 4s and 3 4p orbitals are used in the hybridization, and it forms d2sp3 hybrid orbitals. As the hybrid orbitals are going to be formed, the hybrid orbitals formed are going to be directed in the octahedral geometry. Now, 6 pair of electrons, one from each cyanide ion will occupy the hybrid orbitals directed in a octahedral geometry. In the formation of hexacyanoferrate 3 complex, as it is using n-1d orbitals, it is going to be an inner orbital complex, and we observe, and in this case it is having one unpaired orbital, so it is paramagnetic and a low spin complex. So, iron atom which is having electronic configuration in its outer shell 4s2 3d6. It has 4s2 3d6 in the formation of +3 oxidation state. In the formation of the complex, iron has +3 oxidation state. So it loses 2 of the 4s electron, 1 3d electron. So I'll be having what? 5 unpaired electrons in the formation of the complex. Cyanide ion is going to be a strong ligand, and because of which these electrons present in the 5d orbitals are being forced to pair up. As the cyanide ions are approaching, what happens is the d orbitals, electrons present in the d orbitals begin to pair up, leaving one unpaired electron. So now the central metal ion uses D2 sp3 hybridization, and the hybrid orbitals formed are going to be oriented in an octahedral geometry. These cyanide ions which are having a lone pair of electrons, these 6 cyanide ions which are having a lone pair of electrons will occupy the hybrid orbitals, forming a hexacyanoferrate 3 complex. So in this case, what do we observe is this complex hexacyanoferrate 3 is going to be an inner complex, as it is using the inner d orbitals, and the geometry is going to be an octahedral geometry. As it has got one unpaired electron, it is going to be paramagnetic in nature, and it is a low spin complex. Let us study another example of ion with outer complex. And one such example for ion is going to be hexa-aqua ion 3 complex. In this case, what do we observe is, though ion is having atomic number 26, its electronic configuration is going to be argon 3d6 4s2. Even in the formation of hexa-aqua ion 3, what do we observe is it is going to be in +3 oxidation state, but here in this case it is going to use the outer vacant d orbitals. It is using the outer vacant d orbitals, and the complex is going to be an outer complex. So it uses 2 of the 5 4d orbitals, 1 4s and 3 4p orbitals are used in the formation of the hybrid orbitals. So in the formation of hexa-aqua ion 3 complex, the ion atom uses sp3d2, that is, it uses 1 4s, 3 4p and 2 4d orbitals, undergoes sp3 hybridization, and the 6 hybrid orbitals formed are going to be oriented in the octahedral geometry. In this case, it is using the nd orbitals. So it is going to be an outer complex. And as it has not used the inner d orbitals, the inner d orbitals have 5 unpaired electrons. So it is paramagnetic and it is a high spin complex. So in this example, what do we study is, in the ground state, ion atom has 4s2 3d6. In its +3 oxidation state, it loses 2 4s, 1d electron. So it has 5 unpaired electrons. Though it has 5 unpaired electrons, in this case it is not using these d orbitals, but it uses the 4d orbitals. Because water molecule cannot force the pairing up of the electrons present in 3d orbitals. So here the central metal atom is undergoing sp3d2 hybridization, and the hybrid orbitals are directed in an octahedral geometry. The lone pair of electrons present in the water molecules are now, these molecules are going to come and overlap with the hybrid orbitals. So this complex is going to be an outer complex, It is going to be an outer complex. Hybridization is sp3d2. It is paramagnetic in nature and it is a high spin complex. So what did we study? The inner complex was hexacyanoferrate complex, and hexaaqua iron 3 is going to be an outer complex. Thank you.